give me some restaurant, some good Italian restaurant near Dubai, JBR. So now it's okay, got these restaurants, blah blah blah. Now I want actually to more details about Vinci Resonant. Okay, it got all the information about it, and now it gave us the information. It's interesting. It's interesting. So here is what it told us. Like, here are the details for the Vinci Restaurant UAE. Here's the address, the phone number, the rating, the website. Like, let's actually check the website, for example. If that's like correct, I can go here to the website, and it's actually correct. Like Vinci Restaurant JBR. It's interesting. Now let's try to check hotels that are affordable. Affordable hotels in New York. Let's see. Affordable hotels. Which one is the top rated among these options? I think it's this one, right? Or yeah, it should be this one, Artisan. It's called Artisan. So the top rated among these is Artisan Hotel with a rating of 4.7. That's correct. If you need more details, yes. Yes, what's the price per night there? So what's the price per night? It actually tried to get the detail, like it called the details tool, the place details tool about this hotel, and it got all these details. So I couldn't find the exact night for price. Prices can vary based on the time booking. For the most accurate detail, I recommend checking the website. So for example, from the Google, directly, like from the Google Maps, you cannot know the price, but it actually it gave you the phone number and the website. So actually, let's go to the website, just check if it's like correct or nonsensical. Okay, it's actually correct. Hi everyone. So in today's video, we're going to be creating a travel assistant. And this idea was inspired by a client who approached me and asked me to build a travel assistant that will basically assist people to find new places to go to explore destinations, to explore places in some area. And basically they will just like have some text queries, and the agent will respond to them and basically retrieve information and present it back to them. And it's going to be interesting for them to actually find like new destinations and places to go to and explore. So for this, I'll be using, for the agentic workflow, I'll be using LangGraph as always. And if you're new to the channel, my name is Hussein Younes, an AI engineer, and I've been building AI agents for the past 2 years. And let's get started. So this agent basically will, here's the workflow of the agent. So at the beginning, the user says their query. For example, they want to go somewhere, or they want to explore places in some destination. And then the agent will basically take place, the main agent, which basically plans and executes actions. And here's the set of actions or tools that the agent will have access to. So for example, if we want to go somewhere, like what are the places near me, for example, a good place, like good restaurants near me, then the agent will decide to use the places retrieval or restaurants retrieval tool, and then it will get back the results, and it will just return it back to the user, or it might ask for like additional information from the user to basically provide. So this is the main setup for the agent with LangGraph. This is the LangGraph example repository. I'll just clone it and start from there. But before that, let's talk a little bit about the API that we're going to be using. We're going to be using the Google Places API, the new version of it. And here's the overview. It has the following endpoints for place details, place photos, nearby search, text search, autocomplete. And like, let's see which ones we're going to be using. And I'm building this like from scratch. I have not built something like that before, so we're going to be building it together. So let's get started. So first I need to basically create a new repository. So I will basically go make there travel assistant YouTube. And then I will clone the repository. Git clone. No, then again, first go to travel assistant YouTube. And then I'll do git clone. And then I'll take the URL from here. And I'll clone the repository. Yeah, and here we see the LangGraph example. So it has my agent. It has basically the main agent workflow that I just showed you. And here you can see actually like from the repository that we just cloned, all we need is LangGraph, Anthropic. If we want to use, for example, Claude as our language model, we have Tavily search for Python, a LangGraph community, and LangChain community, LangChain OpenAI. Probably we need also the API. Actually, I'll try to build it with LangGraph Studio. So building with the LangGraph Studio actually makes it easier to debug, to visualize the workflow and so on. And I'm gonna basically drop the folder. Here we have the travel assistant for YouTube. And here I can actually just like drop this folder here. And it's gonna start building the Docker container for it. I think for that also, we need to start Docker. So as a prerequisite for using LangGraph Studio, you need to have Docker installed. And I showed you how to do that in a previous video. Also, you can check the documentation of Docker, how to install it. It's pretty straightforward to do so. So now it's also Docker is opening. Yeah, so basically now I got this error. So I started Docker and I came back to LangGraph Studio and I got this error. So the error says that it cannot find basically my my environment variables file, which is .env. So if I go back to the repository, I see yes, that's correct. I have it like called env.example, not just .env. So I'm just gonna like rename it and put all my environment variables that I need to use, which are basically most probably just the OpenAI API key, and I believe that's all. So yeah, so I've actually done that, and I put my credentials in the .env file, and I put my OpenAI API key, and I put the LangChain API key as well, because I want to use Langsmith, and Langsmith basically gives me flexibility and like more observability and control over what's happening inside my agent, and we also need that for LangGraph Studio. So I'm gonna just rename that to .env. And I will go back to LangGraph Studio and I'll save and restart again. So it didn't find it because it tries to travel assistant LangGraph example and .env. So let me just retry. So now it actually found it, I believe. So now it's trying to build the Docker container for this application, and then it's basically we should be able to see the workflow live here, and we can debug it and basically start building from here. So in the meantime, while it's building, let's just go to the API and see what we can do. So here's Google Maps API. And the one that you actually need to do is we basically need to go to APIs and services, and then we will go to the places API new. So you need to enable that. I already enabled it, so I don't want to disable it. And also you need to create your credentials. So if you go to keys, you'll need to generate like credentials for your project. And here I'm actually using the authentication 2.0 client for authenticating my application, and I'll be using that. Yeah, so let's go back actually to the documentation. So Google Places API documentation. Let's go here. And let's see. So we're using the new API. And here we go to the overview. So let's do text search, which is basically the most like the most common one. So let's check it. So the text search returns information about a set of places based on a string. For example, pizza in New York, which is very close to what we need, or shoe stores near Ottawa. You can put the address as well. The service is especially useful for making ambiguous address queries, which is useful in our case. And it will return actually, let's see what's going to return. So this is the endpoint. and it will return basically the places array that contains all the matching places to the user query, and each place in the array represented by a place object. So we can actually check what a place object is here, which basically like it has a name, it has like type of the place, it has the code, the location, viewport, like a lot of basically attributes. And these attributes are very important actually for us, and we're gonna build data models in our application based on this. So now let's actually check if we have any errors. Yes, we have an error. So let's check. It's quite common. So the Tavily Search API, which contains yeah. So basically, because this LangGraph example application uses Tavily as a tool, as a search tool, so I need to put my API key there, or I can ignore it for now because we're gonna actually remove that node. So yeah, so let's see what is the format of the query, and let's actually try first to have to basically call like to call it in Python. So what we can do is that I can copy this documentation, then I can go to Claude. Let's check the results. So what I'm just like aiming for is just basically the having some kind of like API test code. So let's do it, API test.py, and I'll put the code here. So this is the one to start with, and for the credentials, it's asking for the API key. Instead, actually, I want to use the credentials because, as I told you, I have the credentials, the .json file. So I can actually download that. So let me go here and let me basically download the JSON file. I've downloaded my credentials, the JSON file, and I actually want to be able to use it. So I'm gonna tell Claude to use OAuth instead. Use OAuth credentials.json instead. And let's see. So here's the credentials.json. Should be readable from here. So if I can go LangGraph example and then Python API test. API test, so no, yes. So I need to go layer up, and then I can do like this, LangGraph example, API test. And now it redirected me to login. So now it's gonna basically generate a token based on the user that's logged in. So I already have an I have an application in Google Cloud. So you are a developer. If you're a developer, invalid scope. So yeah, so the scope basically is invalid. So let me actually check the scopes that are needed. Google, let's Google it. So here's the correct scope for the authorization. And authentication. So here, let's try again with the new scopes. I do login, I go continue because I trust the builder of this application, which is me. And here I got the results. So let's check the results. So what was the query? So the query was restaurants in Manhattan, and here are the results that we got. So we got basically the list of places, the array of places, and here we have the formatted address. The display name is Gramercy Tavern, Manhattan, and the Smith. So we have like these information about the places. I think we can get more information about the places somehow from here. Place details, yes. So the place details, basically a place ID uniquely identifies the place in Google Places database on Google Maps with a place ID. You can request details about particular establishment or a point of interest by initiating place details query. So I think we can also get the ID of the place. I do not see the IDs of the places here, but let's check. So the place, yeah, so restaurant in Manhattan. So I think we're doing this, like we're doing the text search. So let's go to the place details. So the places, place, the name, the ID. Here I believe it should return the ID of the place. Let's check the place object again. So yeah, the place should have yeah, name string ID. So I think we should be able to retrieve it. So DOM's results, so search places, the results, query, post is an error, response to JSON. So response v1 places text search. It should give me an array of places. So places, that's exactly what we have here. We have places, we have the object, the place object, but the place object seems to be missing some information here. Okay, so the field mask keys was display name, display formatted address, rating. Let's do the ID as well. Places dot, I think it's just ID, right? Yes, ID. Let's check now. Yeah, so now that we have the ID of the place, so now we can get more detail about the place. So I'll do that. Yeah, so now actually like we have at least connected to this API, which is good. So now what I want to do, I want to define the data models for the input parameters for every text query. For example, for the text search, so expect the text query, the content type, like basically the API key that you have, which we already created the token using the authentication library of Google, and the field mask. So I think that's all we need, which is like fairly simple like data model for the input, because this is going to be a tool. We're going to create a tool for this API endpoint. So that's why. So place details, what we need as an input, just we need the ID and display name. That's all what we need. But I think, okay, I think these are the output parameters, right? Yeah. Or place ID. Okay, so all we need actually is just the place ID. So for example, if we're we're listing some places that the user asked for, then after that, the next step would be to get the IDs of the places that the user is interested in the most, and then we'll display like more details about them. Or for example, we can by default like just call the place, call the place details endpoint as well to get more details about the place. So that's what we're gonna do. So for now, actually, like we identified like two main tools that we will give to our agent. The first one is just like a search for a place using just text query. The other one is actually doing like getting the place details. So actually, I want to test the place details as well. So what I will do here is that places the place ID, so the URL now info about a specific place. So the URL would be the let's just copy this URL, and then here instead v1 places, just I'll put the place ID that we have here. So this restaurant is called like Carmen's restaurant. We can look it up actually on Google. Carmen's restaurant, Manhattan. Yes, let's check which one is this one. 2044th Street. Yes, it's this one. So it's exactly this one. So this is it's an Italian restaurant. So let's see if the details will actually match. So here what we have is the body will be just the I think we do not need the body here because we already have it in the text query, right? So URL, or we can do actually no, I think we need to do this. So let's do it. So here we have the content type. Here we have the API key or the authorization, and here we have the field mask. So the application JSON. Yeah, I think that's it. I think body we do not need it, and let's try again. Okay. No, not found for URL. Actually take that into a little bit of do it after it. And let's do this. Let's just comment out all of this and try, and here we can just copy this, and instead of post we can do just get. Now let's try. Yeah, so we got the display ID. Okay, I think here, what if we do not specify it? What will happen? Fail. I think the field mask is required. Okay, let's actually retrieve all the details about it. Yeah, so these are all the details about this restaurant. And let's check. Oh, it's a very big JSON. Yeah, so this is a summary. Hustling family-style Italian restaurants serving large portions of traditional Southern Italian cooking. Yeah, so I think this matches what's written here, which is like an Italian restaurant. And yeah, so yeah, now I think we're ready to create the data types that we need. And for that, I'm gonna ask actually Claude to do that. So here's what I'm gonna do. I'm gonna copy this input for all of this. So required parameters field, specify the following parameters, the following text search, place attributes, text query. So for example, for the text search, we only need the text query and the field mask. And for the place details, we need only the field mask, I guess. Yes. And the place ID, sure. So we need the place ID and the place and the mask, the field masks. So here, okay. Now using this documentation, please get the create Pydantic data models for the all the input the models for input fields, and then create a data model for called text search that contains many other fields. Yeah, so now I should create like some Pydantic data models for this, and then these data models will basically be the basis to define our tools that will give the agent access to. So in the meantime, actually, we can check the tool base LangChain, which is subclass based tool. So I like to create tools as the Pydantic data models, or like I just like to create them as classes, basically from the base tool class from LangChain, which is basically instantiated from the base model Pydantic class. And here basically we just need to define the following things. Like we can just define, for example, the input model, which we're defining now, and then we can pass this input model as the argument schema. And the argument schema basically is going to just tell the tool what are the input parameters that the agent needs to expect. And this actually will be formatted and passed into the LLM during the runtime for the model, for the agent to know what parameters should it use when calling the specific tool, for example, to find the place. And the beauty of this is that, for example, when you're calling the tool, Pydantic will validate the data type. So if there is an error, it will actually tell the agent, oh, there is an error. You specified here an integer, while it should be a string, for example. So the agent, actually the agent knows that from the like definition of the data types. It will give it the exact like the detailed definition of the data models. But additionally, if it encounters some errors, the beauty of Pydantic is that it's going to validate the data and it's going to tell the agent, you made a mistake about the data type in this place, so please correct it, and it's going to return to the agent, and the agent will basically correct itself. So let's see in the Pydantic. Here are the Pydantic models. Let's see if it actually makes sense. So let's define here something called like models. Or let's just put it in one place. Models by, and here we have it. So we have the okay. So we have the longitude and longitude. We have the circle area. We have the rectangle, location bias, location restriction, eval options, included type. Yeah, so here we're checking. Actually, it created lots of types, lots of attributes for this class, and let's actually check if it's valid. So included type, text search, optional parameters. So yeah, it actually also added the optional parameters like include type, restrict the results, places, matching. Okay, bar. These are types. Bar, pharmacy. The values in table B are only returned to the response. So okay, so there are types of places actually. So they can be like a bar, pharmacy, and so on. So let's check the types. So automotive, business, culture. Yeah, it's actually a restaurant. Can we find restaurant somewhere? Okay, food and drink. Okay, so there are a lot of like attributes for it. So for example, for restaurants, you can find it in food and drink. So there is like type called food and drink, and you can, so basically like this one includes all the parameters that the user can actually specify in the request. And you can see here, if you wanted actually to build it manually, like the search, like let's say you want to have a platform to do search, like to search for places, then you'll need to have like a lot of buttons and like text search for example, a search bar for text queries, like a lot of filters. For example, like when you go to booking.com, there are a lot of filters right on the left side. So that's the beauty of using like an agent, an AI agent. It will basically go to the API and will retrieve all the information that you need from the API if it was like well defined in the Pydantic data model. So it made a good job here. I think it included type, language, code. Of course, if you want to have this in production, you need to check all these types, and you need to actually double check whether it matches the documentation. But for now, like for the scope of this video, I'm not going to be doing that. However, so this is constraint constraint float. There is a problem. So it's not allowed in type expression. Yeah, I think we can ignore, do like type ignore. Yeah, just to ignore this error. I'll do this here. Yeah, so these are the input class config. So this is an example. It actually gave an example, which is very nice. Text query, pair size, circle. Yeah, so the user, for example, might say, I want something that is, for example, if the user already specified their location or the location that they're interested in, then or for example, the address of their hotel, for example, they can say, okay, give me good restaurants near this hotel, and then the agent will predict the circle, the diameter of the circle around that hotel, to predict restaurants that are close to where the user lives. So this is a cool feature, for example, an optional one that you could have. But for the text search, the main one is the required one. So when you put the 3 dots in the field of the type, it's basically it means that it's like required. If it's not required, if it's an optional, you can basically put as none as a default value, or some default value that you think it's makes sense. So yeah, I think that's all for the text search. Now let's do the same, but for the place details. So we're gonna get here, do the same for this. And after that, we need to define the tools. So the tools here were actually very simple tools. In the example, this was just like Tavily tool, Tavily search results, which takes a text query, and basically you can ask the LLM some question, and it will convert that into a query, and it will search the internet and return back some results for you from the internet. So we do not do that here. We don't want to do that here. So what we'll do instead, we will LangChain. Actually, just to save time, I can just copy this example and then we can edit it. Yeah, so we need like text search input. So the text search input is basically just text search. So we can, like, we don't need to define it. We do not need to define the input. We already have that. Now we need like text search tool. So here actually in our case we only have like, so far we have like two main tools, like just the text search and the place details. But if you want something more advanced, like if you have much more tools, like for example you have 10 tools, what you can do is that you can like define like a super tool that defines like the subtools under it. So the agent doesn't need to have access to all the tools. It can have access to just one tool, and the input to this tool will be the name of the subtool that the agent will have access to. So you can just like define everything in single tool, and we can basically create the functions to run everyone each one separately. So yeah, so we have the name. It's called like text search. Text search, useful for to search for places using a text query. And the input will be, we'll just import it from the models. Wait, let's see. But if actually I want to look for my agent in the my agent. So yeah, I can just import it from my agent. So from my agent, import, what do I need? Dot tools from my agent, dot models, import text search. And the input will be just like, it looks like text search. So will be the input parameters, and the tool run. We do not need like a synchronous run for now. We can just have a tool run, and it will be basically like here we do not need that. I believe just like remove all of that, and we can have like quarks, keyword arguments, and here what we return is what we return is the function. So basically here we have we need to create a function out of this. So the same way how we got credentials here. Actually we could just import it from the API test, but for now I'm just gonna put it here. So get credentials. I just need to import some other stuff. Import OS, and I need to import credentials as well. Yes, I think I can do that. So creds equals to get credentials, and here I can also define requests. Import requests. What else I need to do? I think that's all. Just the body. The body I think we can just take from the command line arguments. So the body is works. Print f body request body is equal to body, and here we can check it. So this is how you run the tool basically. So the run function will run when the agent will decide to actually call the tool, and it will also call it with the following parameters, like these parameters here. So now we can actually check that. I can go back here. Oh, I think I gave it the, yeah, no, the text search. Yes, I think that is enough. Or maybe actually I can just give it the IDs, the ID to make it just call the place details later after it like collects all the places, for example. But no, I'm just gonna keep it like that for now. Yeah, and I think that's all what we need. That is all what we need. Turn redirect equals to true. No, I do not want. So that this like return direct, what will happen? The tool can directly return the response back to the user, which we do not know in this case. We do not want in this case. What we want is that every time the tool is called, it will return the results back to the agent, and the agent will actually like reformulate the response and return it back to the user. So I think that's all what we need. And now we can just create the tool. So tools is equal to, we can create the list of tools, text search tool. That's it. And now I believe the agent will have access to tools. So the tool node. Where is the tool node? The tool node is in the nodes. So where does it get the tools from? It gets the tools from tools.tools. So that's correct. So now I think it should be working already with LangGraph. No, we got an error, which is no model named Google. So I think we need to basically add it here. So it's called like Google. Wait 1 second. Python Google API SDK. SDK. It's called, yes, it's called, I think this one. I think we need this one. So Google client. Let's see now. It's trying to rebuild it. Like whenever you make a change, like it interactively basically just rebuilds the whole application. Oh, okay, I need to restart. And I'll just ask what Python library I need for that. Wait, actually I can go to tools, maybe Google. I just don't know the exact name of the library that we need to use. So we can just ask. Okay, Google auth-lib. Google auth-lib request. Okay, I think you can just copy these. HTTP lib. Google auth. Okay, and let's see. Okay, no module named Google auth-lib. I just defined it, so I'll just restart. So now it's building. Let's see. In the meantime, actually, we can add the other tool. So yeah, I think we asked it already to define the place details data modules as well. So I'm gonna put it in modules too. Details to see the parameters. So the parameters are mainly the field mask, but only there are like optional ones, like language code, the language which to return the results with. It's, in our case, I think we do not need it. So we only need the place ID as an input. So the input, yes, it only needs to have the place ID. Okay, we will test this. We will test request region code session token. Yeah. So let's see if it actually built the application, which is really nice. So here we have the action. The action contains now the text search. So let's see the agent. Actually, I think we need to change the prompt a little bit from the example. So in the example, I believe it was being told to do something a little bit different. I don't want Anthropic. I just want OpenAI for now. And let's use just GPT-04 or Mini, which is like the cheapest one. And be helpful assistant. Okay, that's enough. So the prompt is very simple. Just be a helpful assistant, and that's all. And now, hi. Just like, let's see if it's working, at least to begin with. So, okay. No local variable model was not associated with a value. So it should be OpenAI. continue. Yeah, hello, how I can assist you today? I want to go to find a good Italian restaurant. Theme of today's episode is like Italian restaurants. Italian restaurants. Can you please tell me your location, area, your restaurants? Okay. Dubai. JBR. Okay, so as I told you, it tries to like search in a circle. Oh, okay. It's today. It's like, okay, it's encountering some errors. So let's see. And it's like, it was just retrying all the time. So Italian restaurant, circle, longitude, latitude, the radius of the circles, 5,000. No such file or directory. Oh, okay. So now I think like the credentials, like it couldn't find the credentials file. So I believe we need to place it in the container somewhere. So that's what I'm gonna do now. So where you need to put it, I can tell you. So you go to the langgraph.json and then the dependencies part. So the dependencies is in my agent. So this is what gets copied inside the container. Let's try again. Same thing. So now it's still getting file or directory file not found. So that's why I'm gonna go inside the container and see where it's like what's happening there. So here is the langgraph example. Go to files and then we see the Docker file, langgraph API, credentials. I think I should be able to maybe search for files. I don't know. So what I'm looking for now, I'm looking for credentials.json. Credentials.json. It should be next to these files. So Docker file benchmark, etc. Yeah, it should be in dependencies actually. Dependencies, my agent, credentials. So it's actually there. It's actually there. Maybe I need to restart the container. I need to restart. Yeah, so it has been restarted. So let's check now. Find some Italian restaurants near in Dubai, GPR. Okay, I need to specify the models to be used, which is OpenAI. Now I can just continue. Okay, still file cannot be found. No such file or directory. Okay, I'm gonna solve that. So the error happens inside the tool. I'm sure about that. So if we go to oh, okay. Yeah, so actually I solved that error. So what basically I just needed to specify the actual directory inside the container of the token, of the authentication token file, and that's it. So now I'm getting another error. So bad request for URL, text search, fix your mistakes, and let's see. I continue. Let's see if it will try to fix. Okay, so let's open a new thread. Now that we fixed that error, close the logs, messages, delete, open AI. No, actually. Okay, let's see why this is wrong. Yeah, let's actually we can print. Actually, for like for debugging, what we can do the following. We can just define a text search tool. We can just call it tool.run and the following parameters. We can do this. I think let's check the latest one. So we can take this JSON and we can try to call the tool with it. And yes, probably we should get an error. Python LangGraph example. Now if we actually go here, we can see the exact JSON that's being given as an input, and actually this was the JSON input. So we can actually put it here as a test. Yeah, so it's still wrong, and I'm not sure why. But let me try to remove the other fields and keep only the text query. Yeah, it's a bad request for some reason. Request body. So JSON to body. Let's try now. Okay, we got the output. So this was the output. So now let's try. So yeah, we didn't give the body to inside the request, and that was the error. So now we solved it. Let's try again with LangGraph Studio. So let me just update the directory for the token again, and let me just try this request. Retry this request. So now find some restaurants. Okay, now I'm getting another error. Object for is not JSON serializable. Like we need to serialize it, and that's what I've done here exactly. So I think let's try now. Okay, finally it returned something. So okay, so here is what it returned. Okay, here are some Italian restaurants near Jumeirah Beach, Vinci Restaurant UAE. So let me first explain the error, but like let's just first make sure that this makes sense. So Vinci Restaurant, so it's Vinci Restaurant UAE. Makes sense. It says it's located in JBR, which is correct. So what I did now to solve this error was is actually that we needed to make the Pydantic model JSON serializable. So we just needed to extract the basically like to dump the Pydantic model into a JSON object or a dictionary in Python. So that's what I've done for every key basically in the predicted JSON. So yeah, that's what I've done. Yes. So now I'm getting these errors for some reason. So let's just run it again. Okay, variable model, an AI. Continue. Okay, that's it. So basically now here it's working. We can try, okay, how about some Arabic food and cheap places. Cheap places. Also, just give me top 5 by rating, sorted by rating. So this is like a kind of compound query. So how about some Arabic food, cheap places, top 5. So that's what we are shooting for here. Okay, max count 5, min rating 3.5, price levels 1 and 2. So let's check. Okay, bad request. Yes, so it basically returned. So yeah, as you see here, like this is like a very good thing. It first tried to sort by the price levels because I actually asked it for basically some cheap places. And if we go check the price levels input variable, so if we go here, if we go to the models, price level, price levels, it's called it, price levels. So if we check it, we put like numbers as price levels, but it should be actually like inexpensive, moderate, expensive. So it should be like that, not integers. However, it actually corrected its mistakes, and it actually like just removed the pricing range, and it got it correctly. So to solve that, actually, what we can do, for example, is that we can give it an example here. For example, on like a schema, like this one here. Like to give it an example, it's like few shot prompting kind of. So it can help, but ultimately, actually, it learns from its mistakes. So the mistake basically gets back to the agent, and then the agent tries to correct itself. So it actually like searched for Arabic restaurants for the minimum rating 3.5, and the max results are 5 as we asked for, and it gave us these results with their ratings, and they're actually. Basically, at the end, because we asked it to sort it by rating, right? I think we asked it to sort it by rating. Yes, sorted by rating. So the last agent response was actually sorted by rating. So 4.9, 4.8, and actually like these are the names of these Arabic restaurants. And we can check them on Google Maps, and they should be correct. So now, actually, I would, for example, if I want to ask like more details about this restaurant, so I would just like ask it, give me like more details about the first restaurant, but it wouldn't be able to ask it because we didn't yet give it access to the second tool, which is basically the place details. So the place details tool, we need to create it here. The same way we created this tool, which is the text search tool. So we'll create a new one called class place detail this tool, which is inherited from base tool. And for the body, should be very similar to this one. Here we just changed the name, place details. Useful to get more information about places. Yeah, and now here it should be different, I believe. just places. Should be places. Place ID, so which is args. And here by default, let's give it like all the information. Like let's give the agent all the information. Ideally, you would actually filter by the user query, like based on what the user asked for. Like not everything, but just what the user asked for. But for now, let's actually give it like let's display everything, and let the agent actually deal with it. So, however, like last time we tried, it was like very long, but let's try anyway. So quarks.id, I believe. Give me some restaurant, some good Italian restaurant near Dubai, JBR. Okay, so now it's okay, got these restaurants, blah blah blah. Now I want actually to give me more details about Vinci Resonant. Oh, I think. Okay, unfortunately there are no additional details available. That's because we didn't yet give access to the agent to this tool. So place details tool, now we give it access to the agent, and now let's just run this query again. Like we can just basically just retry. Yeah, so now it's retrying. So you see, it get the place details. Okay, the text query, place details doesn't have text query, so it actually got this wrong. They just cancel. Place details. We also should give it place details, not text search. So place details. Now we can try again, I believe. Okay, it got all the information about it, and now it gave us the information. It's interesting. So here what it told us, like here are the details for the Vinci restaurant UAE. Here's the address, the phone number, the rating, the website. Like let's actually check the website, for example, if that's like correct. You can go here to the website, and it's actually correct, like Vinci restaurant JBR. It's interesting. Opening hours Monday to Sunday, 10 to 1 a.m. So probably it's closed now. So here are the features: cuisine, dining options, accessibility, wheelchair accessible, approximately the price range. Like it gives us all the information that we need. We can ask it questions. So for example, is it open now? Actually, it will not answer is it open now because it doesn't know the time now. And that's probably something that we can do later. Is it open now? I'm just want to try. Okay, it's currently closed. Actually, it opens from 9 a.m. It closes 1 a.m. So that's actually correct. The next opening time is 9 a.m. tomorrow. So it's actually interesting. So yeah, I believe that's all. Okay, LangGraph crashed. LangGraph Studio crashed. Let's just run it again. And yes, basically that's what we've built. Actually, we can try some more, like little bit more information about places other than restaurants. Like for example, now we can check hotels. Let's try to check hotels. For example, okay, let's try to check hotels that are affordable. Affordable hotels in New York. Let's see. Affordable hotels. Give us. Okay, here are the Manhattan. Here are some affordable hotels. Okay. Which one is the top rated among these options? I think it's this one, right? Or yeah, should be this one, artisan. It's called artisan. So the top rated among these is Artisan Hotel with a rating of 4.7. That's correct. If you need more details, yes. Yes. What's the price per night there? So what's the price per night? It actually tried to get the detail, like it called the details tool, the place details tool, about this hotel, and it got all these details. So I couldn't find the exact night for price. Prices can vary based on the time booking. For the most accurate detail, I recommend checking the website. So for example, from the Google, directly, like from the Google Maps, you cannot know the price, but it actually it gave you the phone number and the website. So actually, let's go to the website, just check if it's like correct or nonsensical. Okay, it's actually correct, which is interesting. Yeah, if you need any help with something else, feel free to ask. So yeah, we made it. So we built a travel assistant that helps you find like restaurants, hotels, and it gives you the information that you need, and it just basically helps you. It saves you time, like from going manually and checking for such places. You can ask it whatever questions you have, and it does all the work for you. It goes for the API, it retrieves all the functions. Obviously, we can do some more improvements and testing, and we can evaluate the agent and test like edge cases and different query types. And we also we've seen some examples where it failed, for example, with the price levels. It's like it put integers for the price levels instead of like the strings that were required by the API. However, it was able to correct itself, and that's basically because of the nature of this of the workflow. If basically the action returns an error, the agent will know about the error, it will try to correct itself, and then it will call the agent, the tool again within updated parameters, and then it will return the response back to the user at the end. So yeah, that was all for today's video. However, if you're interested in building such agents from scratch, you can check out my video of how I build an AI agent like completely from scratch with LangGraph, and I use something called actually LangGraph Engineer that basically helps you create agents that build agents, or if you want to build agents yourself as well, then feel free to check out the video as well. I explain to you how to do that on your own. Thank you so much for watching. See you in the next video. Bye bye.